Hi, and welcome to the first video of Module 3. In this module, we're going to cover the Swift programming language. There's a feature of Xcode that allows you to play around with Swift, sort of in the way that microcomputers let people play around with the basic programming language in the late 70s and early 80s, which to me was sort of a golden age of programming where you could try out things with very little consequence, and there's very little overhead that you had to um, implement in order to get your programs to run. You could write tons of programs that were less than 10 lines long. You know, of course, that's impossible with things like iOS. There's scaffolding of hundreds of lines that you have to understand even just to modify the simplest programs. And we were able to write a Hello World program without writing any code, and we were able to write a program that shifted some text around from a couple buttons with 3 lines of Swift code. But if we're going to do more than that, we really need to be able to play around with the language. So we're going to use the playground feature in Xcode to try some stuff out. In this first video, I'm going to talk about variables and assignment statements and data types. I'm going to elaborate on that a little bit more, the concept of optionals in the second video. And then we're going to move on and talk about control flow constructs and abstractions, so objects and classes. Hopefully all this will be fairly straightforward, since to be in this class at all, you have to have 1 and probably 2 high-level languages under your belt. And I'm guessing they're probably something like Java and C# or C++. So let's go ahead and get started. So here's the splash screen for Xcode, and we're going to, instead of creating a new Xcode project, we're going to get started with a playground. We get a wizard to create a playground, and we get a choice of what kind of playground we want, iOS, tvOS, or macOS. We're going to go with iOS. What this is going to let us do things like import the UI kit, which is a set of routines related to the iOS user interface if we need to, and also the foundation classes that come from the Next Step operating system in Objective-C, so that we can use those features as well. For now, we're just looking at the most basic stuff. So we're going to create a playground, and we'll call it a test playground. And I'm making these videos in spring of 2019, so I'll name it that. Put it in my directory of my iPhone projects, and I get all it just gives me a couple of lines, and I'm not even going to really need them of commands that it's already executed. It's imported the UI kit, which, as I said, gives us some user interface features if we want. I'll point you up here. We're launching a simulator where we will execute our playground. Over in this part of the screen, the results of executing the playground statements show up. You see, you can go back and edit things. So it's sort of like all the nicest features of those old microcomputers in BASIC without even as much mess as they had, because we've got better editors. So here, the second line declares a variable. Keyword var says that we're going to declare a variable. str is the name of our variable. We could have given our variable a type, but the type can be inferred from the initialization of the variable, where we make it a string. String with a capital S is a built-in data type in Swift. There are a number of other built-in data types, and let's, I didn't want to actually make that go away. And you notice that gave me an error because I didn't initialize, I didn't give a type for the variable, and it couldn't be inferred after I deleted its initialization. So if I do, if instead of having equals and then a text string, I put colon and the word string capitalized with an S, that's a fine variable declaration. That variable is not initialized now, and if I were to try to look at its value, I wouldn't be able to see anything. So let's assign it a value. And we'll assign it the same value it had originally. And say we wanted to output that. There's a print command, and we can put the string. And it shows me exactly what would get printed. And I get my string, plus I get a new line appended to it because I asked it to print it. And that's one of the features of the print command, is that you get a carriage return and a line feed for free with your, the string that you directly output. Print commands, of course, only useful here in Playgrounds because we'll have to output things using the user interface for real iOS projects. But we're just trying to do some stuff here. You can define constants as well as variables. You use the keyword let. You remember this from Module 2. We'll say let string 1 be my string. And I could print that just fine as well. What I can't do is reassign to string 1. I could assign something to string, a second value, and now if I print string or str, I get that same thing. If I were to do this, and I'll get an error hopefully. Yeah, so it tells me down here, it deleted my let, and it tells me it can't assign to str1 because it's a constant. So if I wanted to, what I'd have to make that work, I'd have to go back here, and this is one thing about how we've got a little bit of advantage over the old microcomputers. I can go back and change that, and that fixes things. And now I can print that as well. And my output, you can see, shows up down here, and as well as over here on the right-hand side, I get the value of that particular line. So strings are all nice, but it'd be nice if we could do some other types of variables. And here's one. Actually, I mistyped that. I'm going to leave it like that. And it's going to give me an error, and actually the error message is useful. It tells me that equals must have consistent white space on both sides. So I've created a new variable, and the type of that variable is an integer, a capital INT. We can declare it, if I don't want to initialize it, I could declare it like that. And now, for example, I could say y is x. And y. There are a number of different string types. I'm sorry, of the integer types. If I want to, I can have an unsigned integer. I don't know. I think I'm not sure. Yeah, it looks. I'm not sure I have to declare a size or not. Looks like I don't. But I certainly have types. I can declare in terms of how many bits I want to declare my unsigned integer to be. You can have a uint64, which would be a 64-bit integer. That's a pretty big one. Uint32, I'm pretty sure, is the default. Uint16. You notice I'm getting two things here. One is this little box down here that auto-completes for me. And the other is an error up here because they've already declared this variable as something. So let's give it a new name. That, of course, would be fine. We can now declare a variable x2 whose type is uint16. So I can declare constants of various bases. I've used base 10 numbers here for my 27 and my 5, but if I wanted to, I could use a hex value. Pretty sure it'll print in decimal. I assigned it value AF, and which is, let's see, 10 times 16 plus A is 10, so 10 times 16 plus F is 15, so 175. So it prints the decimal value of hex AF down there. I could assign my X to a binary value with the prefix OB. This should be a 9. See what error am I getting here? I'm not getting any error. That's just fine. Yeah, and it prints 9, which is the correct value there. There's an octal base, but unless you're sort of an aficionado of obsolete Digital Equipment Corporation machines from the 60s and 70s, you're probably not going to use that, so I'm not going to go into introducing it. Now, there are floating point types. Float and double. Float being a 32-bit floating point value and double a 64-bit. So we could say F1, there F1 is 1.0025, 26, and let's say there F2 is a double. F1 is implicitly made a float, by the way I wrote its constant. And I want to talk a little bit about type conversion. Let's see what happens when I say F2 equals F1. That should, you would think that that's a reasonable thing to do because a double has more precision than a single precision number. And in fact, that works. But if we wanted to do something like that, where we're assigning the float, the integer value, x1, where x1 is a uint, that doesn't work. There's very limited implicit type conversion that can be done in Swift. And if you want to do something like this, you've got to explicitly cast the variable that you're assigning to the type of what you're assigning it into. Now that worked, and now I can print F2, and it should have the value that X1 did, which is 27, but it'll be 27 as a floating point. And we see that it prints that way, 27.0. So we can do type conversions. We just have to be sort of explicit as we're going about it. And you can play around with in a playground and sort of see what you're able to do. Let's see, for example, what happens if we try to cast between our int types. We can't assign a value of type uint to a value of type uint16 if we go the other way. Can't go that way either. So what we would have to do again is to cast this uint16 to a uint before doing the assignment, and that works. So the cast always looks like this. It's the type name, and then parenthesis, and then the value or expression in the old type, and a close parenthesis. Likewise, if you're doing an expression, you've got to, everything in the expression has to match up in type. So if we were to say something like f2 equals f1 plus 3, we can get away with that because it'll up convert the 3 to a float. But if we tried to do it's not going to like that because the right-hand side converts to a float, and then we're trying to assign that to x1. So the way we would fix that would be to convert the whole expression to a uint. And I'm not sure what this is going to do. I don't know if it's going to round or just say that it can't do it. Well, it seems to like it. Let's see what we get. I'm guessing 4. Now, something that sometimes happens is happening to me, and I don't really understand it in playgrounds. I'm not getting any output. It's sort of stuck. So rather than hypothesize about what's going on with this, I'm going to bring this video to a close here, and I'll see you in the next video with some explanation.